Chris Lado. Welcome to Lado Files. What's up, guys? Welcome to the channel. That was on Ross Coulthardt's and Bryce Sabell's new documentary. This was handed to them to basically make changes to one of their shows, right? A horror show. They weren't doing it correctly. And these random dudes showed up with some key information. So sound, light, and frequency. This video is actually my submission to Kurt Jaimungal's Physics and Consciousness Contest, Pace 1. That's on his Theories of Everything channel. Kurt's an amazing YouTuber, and he is making this contest to try and get more physics and theories out there. So happy to contribute. Check out his channel for more information on the contest. You have until the end of October. Sound, light, and frequency. You'll have to stick around to the end to see the real breakthrough, the mind warp, when we throw sound in there. But first, let's see how we can build a Turing complete computer. How do complex patterns emerge from simple starting parameters? Thanks for being here. Don't forget to smash that like button. If you do like this content, subscribe to get notifications of my future videos, and you can support the channel at patreon.com/Chris Lado and get access to exclusive videos and early ad-free access. Thanks again for being here. Let's get to the video.
Life gained popularity after appearing in a column written by Martin Gardner called Mathematical Games. In the October 1970 issue of Scientific American, Gardner talked about the fantastic combination of this new solitaire game called Life. That was going to become one of his most successful columns. Like chess and Go, Life is played with pieces on a board, but unlike chess and Go, it requires no players, a zero-player game with no winners or losers, which result is fully determined by the initial configuration of the pieces on the board.
So Conway's game of life was invented many decades ago and has turned into a form of mathematician's game. Okay, from very, very simple starting parameters, extremely simple. There's only 3 rules in this game. Okay, 3 rules. What you can get is very complex gliders, things flying around, replicating patterns that seem to come about from nowhere, right? Basically, complexity can arise from simple rules. This shows us also with evolution. So this game, right, which shows complex structures, only has three basic rules.
A player is only needed to advance the state of the game to the next turn, a generation, following 3 simple rules. 1. Survival. Every piece surrounded by 2 or 3 other pieces survives for the next turn. 2. Death. Each piece surrounded by 4 or more pieces dies from overpopulation. Likewise, every piece next to 1 or no pieces at all dies from isolation. 3. Birth. Each square adjacent to exactly 3 pieces gives birth to a new piece.
So that's it for the game of life. 3 simple rules to get all these complexities, right? You have to have survival, okay? You have to have deaths, and you have to have births. That's it, okay? That is it. You may be asking yourself, Chris, why are you talking about this? Sound, light, and frequency, secrets of the universe. Why are you talking about this Go-looking game? The point is, from these 3 simple games, okay, you're able to create. Humans have created Turing complete computers. Turing complete computers. Think about what that means. That you can process using just this simple setup, right, of the game of life.
Showing that logic gates and memory blocks can be built in a system is basically enough to prove that, at least in theory, we can build a proper computer in it. These systems are said to be Turing complete, after the English mathematician Alan Turing, who pretty much came up with the theory behind modern computers. As it turns out, many other games that, pretty much like life does, allow players to build structures that can evolve are Turing complete. Minecraft, Infinifactory, Prison Architect, Cities Skylines, Baba Is You are all unintentionally Turing complete. And many players, myself included, enjoy the challenge of building actual computers in them.
So look at this. This game, simple rules, builds complexity up to a computer. Okay, you can literally build a computer in this game. Computers can come about from simple rules. Okay, so this is a pattern. Patterns that basically form based off very simple rules, complex patterns forming off of just simple rules and entropic time. Okay, you need generations. We need entropic time. Okay, you need changes in generations. So what does all this have to do with sound, light, and frequency? Okay, we're almost there, guys. Don't worry. I think it'll be worth it. So let's go through first frequency and light. So frequencies of light are all on the electromagnetic spectrum. The electromagnetic spectrum is the range of frequencies of electromagnetic radiation and their respective wavelengths and photon energies. So all things that we know about are on the electromagnetic spectrum, propagated through electrical waves and 90 degrees out magnetic waves. So we're all made up of electro and magnetic waves. This is all light based on the wavelength. The spectrum covers waves with frequencies ranging from below 1 hertz to above 10 to the 25 hertz. The electromagnetic waves in each of these bands have different characteristics, such as how they are produced, how they interact with matter, and the practical applications. There is no known limit for long and short wavelengths. There is no known limit to long or short wavelengths. Think about that. So this is the electromagnetic spectrum in an easier diagram. Okay, so this is a diagram showing various properties across the range of frequencies and wavelengths. So up here, this is the actual wavelength of the wave. Okay, so as it gets longer here, so this you have 10,000 meters long is this wavelength. Okay, the frequency will decrease. So now the frequency decreases. Temperature is on the bottom. Okay, so as we go to the right here, energy is going to increase. So gamma ray, X-rays, ultraviolet, these are high energy waves. They're so small, so much energy, they can cause damage to our cells, cause cancer, etc. High power, small wavelength. But now if you search online, you will not be able to find, or if it's very difficult, I could not find any other electromagnetic diagrams that went past this. Right, if you look here, it all ends. Oh, there it is, radio waves, that's all we got, okay? Ends here. We go from atomic nuclei up to about buildings. That's where we're going to stop. Okay. And in fact, after that, anything longer than this, we just call long waves. Okay. Everything. And I'm going to show you there's a lot of scale out there to look at. So what this shows is really, to me, is patterns of life. Okay. Patterns of actual life, because we have identified life down here at 10 to the minus 9. 10 to the minus 9 now is nanometers, and that is the size of DNA. So you're actually structured. Your programming, all of our programming in each one of our cells is from tiny bits of code, tiny bits of life, if you will, down at nanometer scale, 10 to the minus 9. Cells now are at 10 to the minus 6. Okay, these are going to be your single cells, okay, your little neuron cells, neuronal cells. Now we can start seeing animals up to humans, okay, at humans. So I've repeated this scale here. You see atomic nuclei here. Okay, I put a little ticker marks here. These are 3 zeros, okay? 10 to the 0 here, and then we have 10 to the minus 3, 10 to the minus 6, etc. Okay? Down at the bottom, we have our temperature as well. So what I'd like you to do now is go through a little mental mind experiment with me, okay? I want you to close your eyes. And now, imagine where do you begin? What is you? Okay, if you feel your finger, you feel a cell in your finger, okay, you know that's part of you. But does that make up the actual conscious entity of you? Okay, so where do you actually begin? Okay, so if we go back, I mentioned the DNA. So 10 to the minus 9 here is where your DNA is actually encoding. Okay, but now let's zoom in. Let's close your eyes again and imagine you're zooming in to 10 to the minus 6, super small, down to one of your neurons, okay? Because I think we can all basically agree that we are made up somehow, our brain is related. So if we zoom into one of our neuronal cells, and we imagine looking inside, we'll see our DNA in there. We see the cell of our neuron. But that is not us, is it? That's not you. You're not your neuron. Okay, as far as I feel like I am the conglomeration of my neurons. Okay, I actually don't care if a few neurons die. I think we've tried to kill neurons before. But now all of the neurons make up me. At some point, this conscious entity comes in, right? And now it assumes that this is the end. This is it. This is me, okay? But that neuron is still you, isn't it? In some way, at least makes up you, makes up parts of you, and has your DNA coding in it. Okay, so that was the mental experiment, but now I want you to remove that thought. Take your humanism out of the equation, okay? Because this is the problem looking back in history. Any new views, any new paradigm shifts, or different ways to actually look at the universe are always met with what problem? The human problem, okay? We can never imagine that anything is bigger than us. It's all about us. We are the center of the universe. And we also cannot imagine that there's immense scales. Imagine the numbers. We still don't know how many cells are in a human. Last I heard it was 37 trillion. Before that was less than a trillion. 15 years ago it was less than a trillion. It's hundreds of billions. We still don't even have a clue, right? We're orders of magnitudes off. So now let's imagine we remove your ego. We remove the human ego. We're just looking at this as a system. Okay, so DNA combines into cells that combine into larger organelles, parts of your body, different things, different functions, into you, okay? But remember, we're not stopping there. Okay, we've removed the human conscious from this equation, right? So what is a human? If we put a human out in space, they will die immediately, right? Not surrounded by the structure, the overarching larger organism, potentially, okay? Without a family, humans are dying. Look at homeless people in the streets. Why? They have no family support structure. This is what happens to humans if they're thrown out without being a part of the actual system. Okay, so the family, the tribe is 10 to the 0. So this is 10 meters, essentially, okay, about the size of your house. If you imagine a little cell. But what does tribes make up? Okay, if we look back at ancient humans, you imagine nomadic tribes running around, little groups of humans. To cell, they send out hunters, gatherers to gather resources for the cell. Okay, they have their own culture. Okay, there's some way that that tribe actually replicates into the future. Okay, so basically the structures can repeat. As we go up to towns now, tribes go into towns, okay, smaller villages, etc. Now grouping into, as we go up to 10,000 meters now, is cities. So now we have cities at 10,000 meters. If you imagine a city is itself an organism. Okay, it needs resources. It has waste. It needs to actually continue into the future. Cities die. Cities replicate. Cities spread into nations, right? So we get to states. Now we go up to nations. Look at nations. If you can remove the humanism from the equation, nations appear to be, obviously, to me anyway, living, breathing organisms, okay? They don't care about the cells. The same way you don't care about one of your hand cells, right? I just killed literally 1 million hand cells, or who knows how many. But it doesn't matter, okay? I don't care. I should care, I guess. Same way the nations have millions, hundreds of millions of cells. And if you include other cells besides human cells now, they have up to trillions, right? So now, nations, I argue, is the largest organism on the planet, except the planet is itself an organism, is the argument here. As we go up another, so this is 10 million meters now, we get to planets, okay? And I think the Gaia hypothesis has been around for many decades. John Lovelock has promoted that to a great extent. I think the Earth could be seen as an organism, right? If it's hit by a meteor or if all the air goes away, it will die. If the sun goes away, it will die, okay? So Earth can be seen as a organism if we go up to 10 million meters across. But why stop there, right? Because look at this. 10 to the 0 effectively for humans. If we just go 6 zeros up, we get to the planet, right? 6 zeros down is just to single cell organisms. Okay, we haven't even gotten to DNA, right? DNA is over here. So 9 off. The same distance in scale and frequency from you to DNA is the same as you to the sun. Okay, actually less. Sun start about 10 to the 8th meters. That's millions of meters. So now you have stars. But stars have, this is the range, okay, stars, there's quite a big range of stars size. And in here I also noticed stellar mass black holes. Stellar mass black holes seem to be about the same size as stars, okay, but related to stars in some manner. So what if we go up another? Now we go up to 10 to the 12, that is 10 trillion miles, and this is 1 light year. Okay, that's 1 light year. And this is where we start getting into solar systems. So solar systems start less than a light year and go to tens, I don't know, maybe hundreds of light years across. Okay, but what's after that is the nebula. Okay, nebula. These are these large structures out there. We're seeing all different types, all different forms of nebula out there. What do our scientists think they are? Right? Just gas and dust out there. Couldn't have any actual form or function, right? Why? Because we can't imagine that it would have any form or function, right? Because everything comes down to humans. All comes down to us. So these are your nebula, all different types. Nebula now build into galaxies, okay? And in between there's your supermassive black holes that I mentioned. So we have stellar mass, supermassive black holes. So are there actual black holes in between? Are there intermediate or are there larger ones even? So these are your supermassive black holes into galaxies. Galaxies start at the thousands of light years across and go to almost millions of light years across. And again, galaxies are all different types of shapes, sizes, form, and function. If we go up another order of 3 magnitudes, now we get to clusters of galaxies. Okay, these are clusters of galaxies, and there's all different types. There's regular clusters, irregular clusters. Again, different types of structures formed at this size called clusters. But again, still going, right? We are still going to 21. So what happens at 10 to the 21 is now we get into large structures. Okay, these are, looks like large structures. They call them voids, filaments. Okay, you're looking at these things that we can't identify, but know that there is some form of large structure in there. There is a form of large structure. Going finally to these large structures build into the full universe. Okay, the full universe, so large structures end about 10 to the 24, and the universe is at 10 to the 26 meters. I believe trillions of light years at 27. So this is the universe, and the universe has a temperature of 2.73 Kelvin. Again, all black bodies radiate. This is the temperature of the universe that we can see, okay? Pretty crazy, right? And that's the big, right? I didn't even mention the small. So let's go to the small as well, other side. So we go back, okay? What do we have? What do we have below atomic nuclei? 10 to the 12, 10 to the minus 15th now, we get to protons, neutrons, okay? Those kind of particles is 10 to the 15th. And then the smallest things we know about are quarks, gluons, these sort of elementary particles. We say elementary particles, but are they? 10 to the minus 17th, okay? So not even at 10 to the minus 18th. So in this case, this is everything. So now the spectrum is complete and probably not fully complete. Remember, there's no known limits. No known limits. And again, it's just frequencies. If you remember, we don't actually touch, right? We don't actually touch.
But maybe there's hope.
Nothing's actually touching here. It's all frequencies and relationships and perspectives. Okay, so that could make sense. So now, I remember, I said I was going to blow your mind. I've talked to light, frequency. I set it up with this complicated game of life. Okay, so what does game of life show us? Complex patterns can come about from simple setups. Okay, from the same simple starting conditions. What does that mean? Is that we have patterns. I mentioned sound. Now here's it going to come in. How does sound come in? What is a key point of sound? It's very interesting that we haven't been able to find out. A repeatable pattern in sound. What do you have repeating patterns? Octaves, right? You have octaves. We have different notes that provide different tones, different experiences, different functions maybe. That happens every doubling of hertz, okay? But what happens when I looked at this is I said, where are the repeating structures? The most obvious structure to me relates to the atom and the solar system. Okay, if you just look at an atom, 99.9% of the mass of an atom is in the nucleus. It's in the nucleus. Very powerful. It has these small minor elements running around. You have electrons with charges running around, okay? Now if we look at the solar system has a nucleus, the sun. 99.9% of the mass in the solar system is in the sun. It has these particles running around, these planets, right? Charged particles. The Earth has a charge. Okay, we have a magnetic charge. So it just looked like a repeating pattern, the same as atomic nuclei. Okay, so if we look at atomic nuclei, they are 3 orders down from atoms essentially. And that is the same as stars to solar systems. Okay, so how could this be? How could we have repeating structures at such vastly different scales? Well, according to this paper, the quantitative comparison between the neural network and the cosmic web, this is from 2020, out of Italy, they found statistical correlation between the galaxies of the universe and neurons in a brain. Statistical correlation in density, in structure, and in pattern. Their conclusion was somehow at these amazingly different scales of life, you can have similar patterns, okay? So let's look at that. Let's look at these scales that I just mentioned. So I assigned an atom, an A. All right, I just gave it a letter. And then I said, okay, solar system is also an A. But now look at this, man. Look at this. If we go in between, it matches exactly to an octave in music. I went A to B to C, D, E, F, G, and then the pattern repeats. It repeats just like in music, man, just like in music. It repeats at 10 to the 21 zeros. That's what we have. So now that example I just gave, so galaxies to, what was it? Neurons. So we have cells here is a B. Okay. Scroll it over. So A and now B. So we have cells to galaxies. Look at that. It matches up. The pattern matches up. And the pattern keeps matching up. That's what's crazy. Look at this. Okay, atomic nuclei is a G. If we go to a G now, is stars. Okay, let's look at what's the universe. Okay, the universe is close to an F. So basically the universe is similar in structure to a life planet, to a planet. That sort of structure. Now let's look at humans. Okay, let's look at humans. Humans are a D. Okay, we'll go to a family unit. So there's only one octave on this. We can only see one octave, right? But as we go up now, where's your D? Is right here at large structures. Okay, so large structures. So a structure similar to humans, some sort of structure should be emerging here at D, at this size, okay, which is immense. I mean, just immense. Imagine that. Could this be the cosmics that we hear about? You know, these cosmic organisms. And, you know, they could be interacting with us because, look, we can interact. Not yet, but we can at least see down to our DNA, okay? We can easily interact to the cellular level, but soon we'll be able to interact to the DNA level. And now quarks. What about when we can figure out what's going on with quarks and look past that? Could we actually find organisms that are off the scale, smaller than we can imagine, but somehow related to us in some sort of structure? Other things here, protons, 10 to the 15 is an F. If we go up here, is now the same as a planet. Okay, so a proton and a planet makes about the same sense, right? I mean, think about it. Those particles are charged small particles. And now that would be what the universe is. Okay, so that's the one repeating structure we can actually see is the protons and quarks, the E's and the F's, right? So we can see protons is an F out to the universe. So if it continues, if it keeps going, then most likely the universe is just a proton and the next scale system up of repeating octaves of sound, light, and frequency. Boom! Hope you guys enjoyed it. Please smash that like button. It really helps the channel. Subscribe to get notifications of my future videos. And you can always support the channel at patreon.com/Chris Lado. Join Patreon if you want to get special access, exclusive videos, behind the scenes, how I actually come up with these videos, and help with making future videos, as well as ad-free early access on Fridays. Kurt Jaimungal's contest goes until the end of the month, so 31 October. I encourage you guys to make a video and put it out there, okay? I know it's tough to publish, but just do it. You can add to our knowledge. Okay? Let's break through. Let's combine humanity. We can aim for peace. We can figure out what's going on with this universe and why do we want to see these patterns? What is the point of being able to see these patterns? Is to add some clarity, right? You don't have to be confused. Why did Russia invade Ukraine? Well, because Russia's acting as a not very smart, non-sentient organism. Okay, it's just doing what it does, what Earth life does, kill or be killed. If we can understand that now, we can communicate. Maybe we can realize we're all together, we're all on the same little ball, and we're actually all linked. We're all together in this, okay? So maybe it'll help us to actually work together for a more positive future. We can all hope anyway. Make a video if you have a chance. And the guts. Thanks for being here, everybody. Take care. Peace.